All right, so get ready, because today we're diving deep, really deep into the mind of Stephen Hawking.
Oh, this will be good.
Yeah, and we've gotten a ton of material about his work, so it should be interesting. Black holes, the Big Bang. We're going there.
He really wasn't afraid of the big questions, was he? Hawking completely changed how we understand things like, well, everything, really, the cosmos.
And one of the biggest things he flipped on its head has to be black holes, right? I mean, we always thought of them as the end of the line. Nothing gets out. End of story.
Well, yeah, if you're thinking about it the old way, but bring in quantum mechanics like Hawking did, and whoa, suddenly things aren't so simple anymore.
Okay, bring us up to speed.
So entropy, right, it's always increasing. That's one of the universe's ground rules. Basically, things tend towards disorder.
Gotcha. The universe likes to get a little messy.
Exactly. But then we have black holes sucking up everything around them. Wouldn't that be like the opposite of increasing entropy?
Yeah, good point. It's like they're neat freaks in a messy universe.
And this is where Hawking changed the game. He said, what if black holes aren't actually black, like totally black? What if they radiate energy because of quantum stuff happening right at the edge, at the event horizon?
So black holes leak.
Kinda. It's called Hawking radiation now. This radiation, it carries away energy, and here's the picker entropy too, so it's like a balance. Sure, the black holes suck stuff in, but it also slowly radiates its mass away, and that keeps the universe's entropy going up.
That is wild. No more eternal prisons, huh?
Well, not exactly eternal. Hawking figured that black holes actually evaporate over, well, ridiculously long periods because of this radiation. And remember that whole entropy problem we talked about? Well, this radiation is actually the key to solving it.
Right, I'm hooked. How does that work?
So black holes, they have their own entropy tied to how big their event horizon is, and the more a black hole eats, the bigger that horizon gets. It's mind-bending. But think about it. Bigger horizon, more entropy. This increase actually cancels out the decrease from swallowing matter, so that universal rule of increasing disorder stays intact.
So black holes aren't just evaporating. Their whole existence is tied to this entropy thing, right?
Exactly, and there's more. This radiation, it's not just theoretical. It has a temperature.
Wait, are you saying if we could get close enough, not too close, obviously, we could actually measure a black hole's temperature?
In theory, yeah. And since it's emitting radiation against a super cold background, a black hole would actually look like it's glowing. Subtle, sure, but it changes everything about how we understand them.
Glowing black holes and entropy. Stephen Hawking, he didn't play around. We've gone from thinking of black holes as cosmic vacuum cleaners to these crazy, complex objects following some of the most fundamental laws of physics.
And that's just the start. This black hole stuff was just the warm-up. Then he turned his attention to the Big Bang.
Yeah, if there's one thing that just screams mind-bending mystery, it's definitely the Big Bang. How do we even begin to unpack that?
Well, Hawking went there. He said, to really get the Big Bang, we need to rethink how we see time itself.
Rethink time. As in time is an illusion. We're all in some kind of matrix situation.
Not quite that dramatic, but he introduced this concept, imaginary time. Stay with me here. This is where it gets a little out there.
Okay, I'm all ears.
So, picture this. At the very beginning of everything, in those first moments, time wasn't time as we know it. It was like another dimension of space.
Okay, you officially lost me. Time as space. How does that even work?
I know, it's a brain twister. Think of it like this. We move through space, right, up, down, left, right, forward, back, 3 dimensions. And then we have time always moving forward one direction.
Okay, I'm with you so far.
Hawking said that way back at the very beginning, time wasn't like that. It was like a 4th dimension of space, like north, south, east, west.
So instead of a timeline from the past to the future, it's more like a direction.
You got it. And that's where he brings in this idea of the South Pole. You can't go any further south than the South Pole, can you? It's not the edge, it's just a point. Hawking said the Big Bang was like that. Not some explosion at the edge of time, but a point in this imaginary time, like the South Pole of the universe.
So not a universe exploding out of nothing, but more like the universe always being there, but in a state we can barely even imagine.
That's the idea. Mind-blowing, right? But it solves some issues physicists had with the classic Big Bang idea. It means the early universe wasn't this infinitely dense point, a singularity. It was smooth.
Wow. Okay, so black holes that glow in time that's like space. One thing's for sure, Stephen Hawking was not afraid to think differently.
Nope, not at all. And his big ideas didn't stop with just the universe. He was really concerned about what happens to us humans, our place in it all.
It's amazing, isn't it, how Hawking was always pushing the limits, not just with, like, cosmology and all that, but with what we could become as humans. He really believed we could reach the stars. Literally.
Oh, absolutely. He saw it as essential. Becoming multiplanetary, that is. Not just some cool idea, but necessary for survival in the long run. We're kind of vulnerable on this one planet, right?
Yeah, it's like putting all your eggs in one very fragile basket.
Exactly. And he talked about asteroid impacts, which, sure, those are a worry, but what he really focused on was us. How we might mess things up ourselves. With nuclear weapons, climate change, you name it, those were the real dangers.
So it's not about escaping Earth, really. It's more about, like, learning to live sustainably, whether we're here or on Mars or wherever.
Right on. And Hawking actually thought that the challenge itself, getting to space, figuring all that out, that could be what saves us from ourselves, you know?
That's really interesting. You're saying that becoming a spacefaring species would force us to deal with some of our own, well, self-destructive tendencies.
Exactly. And it's not just survival either. He also saw it as a way to, like, rekindle that sense of wonder, inspire a whole new generation of explorers and scientists venturing out beyond Earth. It could change us, not just how we live, but how we think.
Like the overview effect astronauts talk about. Seeing Earth from space. Realizing how small our problems really are.
Exactly. That change in perspective, realizing we're all in this together, that's something he really hoped we could grasp. He said, leaving Earth will also give us a new perspective and cause us to look outwards rather than inwards. It would also unite us to face a common challenge.
There's something kind of beautiful about that. That maybe trying to do something as hard as colonizing another planet could help us get over the things that divide us here on Earth. But being realistic, space travel is, well, incredibly difficult. And expensive. Was he being a bit too optimistic?
He knew it wouldn't be easy, that's for sure. But he also had a lot of faith in us, in human ingenuity. If we could just focus, work together, he really believed it was possible. And look at what's happening now with SpaceX and all the private companies. Things are changing fast.
Yeah, there's definitely a new energy around space these days. But even if we do make it to Mars, build a colony, how do we not just repeat the same mistakes?
Ugh, the million-dollar question, right? Hawking grappled with that too. He knew it couldn't be about just recreating Earth somewhere else. It had to be about changing how we think, how we act, from the ground up.
So it's not escaping to another planet, but using it as a chance to make a better future.
Exactly. A chance to learn from our mistakes and build something better, something more sustainable, more in balance with the universe.
It's a hopeful vision, and I think it resonates with a lot of people. But we've been talking so much about Hawking's ideas. It'd be great to hear about him as a person. What was he like?
You know, he was extraordinary, not just brilliant, but his spirit, his sense of humor. He went through so much, but never lost his zest for life, his ability to connect with people.
We always hear about the stereotypical genius who's, like, brilliant, but kind of out of touch. Doesn't sound like Hawking fit that mold at all.
Not one bit. He had a playful side, you know. Loved to make appearances on those popular shows like The Simpsons, Futurama even.
No way. The Stephen Hawking on The Simpsons. Seriously.
Seriously. He had a great sense of humor, did not take himself too seriously, and he loved experiences that pushed his own boundaries, even with all his physical limitations.
What do you mean by that, pushing his own boundaries? Give me an example.
Well, for example, he went on a zero-gravity flight.
Wait, are you serious? The man who could barely move, experiencing weightlessness?
Yep. They had a specially modified plane, let him float freely for a bit. And you know what he said afterwards? It was wonderful to float weightless, free of my wheelchair. I could have gone on and on.
That's just amazing. He had such a thirst for life, never let anything hold him back.
Absolutely. He was proof that we can overcome anything and never stop exploring with our minds and with our lives.
Well said. So we've talked about black holes, the Big Bang, even colonizing space, and we got a glimpse of the man behind the theories. What else is there?
Well, even with all his discoveries, Hawking knew there were still big questions out there, the really big ones. And they're not going away anytime soon.
Those are some big questions, all right. Some things you just never really figure out, do you?
I guess not. Those really fundamental ones, they really stayed with him his whole life. Why are we here? Where did it all come from? The mysteries that have always been there for scientists, philosophers, everyone.
It's interesting, right? Because we've talked about all these incredible discoveries he made, black holes, the universe itself. But it seems like he also knew that science couldn't explain everything.
Oh, for sure. Science is powerful, don't get me wrong. It helps us make sense of this world, the universe. But all the answers, we're not quite there yet.
Yeah, and that gets forgotten sometimes, you know. It's not like a finished book, science. It's more like We're still writing it.
Exactly. And Hawking, he lived that. Always more questions, always pushing the limits of what we thought we knew.
Which brings us back to those big questions, right? Why are we here? Where did we come from? Is there even a point to it all?
Questions that have been with us since, since the first humans looked up at the stars and wondered.
We're hardwired for it, aren't we? To search for meaning, for purpose?
Maybe we are. And science might not have every answer, but it can definitely, light the way.
Like every new discovery, every piece of the puzzle. It just makes you realize how much more there is to know,
For sure. And that sense of wonder, that drive to explore, I think that's what makes us human.
I love that. It feels like Hawking's legacy, in a way. That we should never stop exploring, never stop asking those big questions. Just keep looking up in awe.
He was definitely an inspiration. His work pushes us all to think bigger, aim higher, never settle for easy answers.
Well said. So, I think that about wraps up our deep dive into the incredible mind of Stephen Hawking. From black holes to the Big Bang, space travel to the meaning of life, it's been quite a journey.
It really has.
So until next time, everyone, keep looking up, keep asking those big questions, and never ever lose that sense of wonder.
Great advice for life no matter what you're exploring.